Hello friends, this is Dr. Antoine Yungeko, your coach in data analysis using R2. In this video, I'm going to show you how you can analyze your social network by analyzing degrees and prestige. I'm going to work on the same data set that I have been using since my presentation on social network analysis. Now, before performing such analysis, you need this library iGraph. Let's learn this command. If you do not have this library, you need to install by clicking on Tools, Install Packages, and you tap the name iGraph when you are connected to internet. If you found this video interesting, you can share it, and you can also subscribe to our channel not to miss the next video related to deep analysis of social network. Let's learn these comments. Now you see this comment here is to indicate where I saved my datasets. Dataset created related to course analysis. Now this command you see here, friends, is just to import my data in Rstudio working environment. This is the name of, you see the command is read. This is the name of my data set. Header to import the name of variables, and sep to show how data are separated. And let's run these comments. Now this comment here you see is just to create our network, social network, and I save the result in course network because I'm just dealing with course. I created some numbers to indicate how each number called in other number. Now let's run this command. You see here I'm working on my data set I imported, and I indicated that I want a network which is directed, because remember when I introduced to you the social network, I said there are two kinds of network, directed and undirected, but here I'm going to use directed network. Let's run this command. Now I can make a visualization of my network by learning this command. You see the result of my network is saved in course net here. Now this is said city you see here is just to get the same visualization when I run again my plot. Now you see I'm plotting the result here. This is where I saved my network. This is a vertex color. This is the vertex size, and this is edge color. You can just change the color of edge if you want to change it. Because here you see I use red. Yeah, I can just use any color, whether I can use pink, I can use yellow, I can use blue, and so on and so forth. Now this is how our network looks like when you make plot, when you make a visualization. Now you see, for instance, here, friends, now you see this number called this one, this number called this one, this called this one, this number called this one, and you see here, this is what we call out degree, which means outgoing rings. And you see, for instance, this one, this number called this one, this is what we call in degree, in rings, in degree. For instance, this number you see calls this number called this one, and this one also called this one, but this number called this one, but this number didn't call this one. This is how our social network looks like when we make plots. Now I can perform some analysis. When we are analyzing degrees, that means we are analyzing how our social network is connected. That means we are going to count for each node or for each number how many connections the number has. When we talk about degree centrality, it refers to the number of connections that a particular node has with other nodes, actors in a network. Degree centrality is the ability to directly reach many nodes. It shows the extent to which certain actors are more connected than others. A node's degree centrality refers to the number of ties it has or the number of relationship it has. Now, we have three kinds of degree analysis. We can have what all degrees, we can have in degrees, and we can also have out degree. Now, when you want to analyze the number, the total number of connection a number or a node has, you have to use this command degree. Now you see we are working on the results of our network, because when I make a graph of our network, social network, I save the result here. Now all comments related to in degree, out degree, or degree will be calculated based on our social network created in this step. If you found this video interesting, you can share it, and you can also subscribe to our channel not to miss the next video related to deep analysis of social network. Now let's calculate, for instance, the number of degree, total degree. Now what will change is only this comment, this part, because when you indicate the mode, where the mode can be all, when you want to calculate all degrees, or it can be in when you are interested, for instance, incoming calls, and it also can be out degree when you are interested in outgoing calls. Now let's run this comment to see the total degree for each number. Now as you can see here, in terms of visualization or in terms of result, this presentation is not very good. Let's use data frame. I'm going to use a data frame to make a better visualization. Now when you want to use a data frame, you just need to save the results in core or degree. This is a name that I give to my degree analysis, and I'm going to create a data frame based on this name, this one, because I will set, you see, as you can see, this is the same comment here, you see, friends. Now let's run this comment, then I'm going to make a data frame. Now let's run this comment to make a data frame, and this comment is to make a visualization or printing the results. Let's run all these comments. Now you see I'm calculating all degree. As you can see here, friends, now you can the visualization or the result, it makes a better presentation. As you can see, this is the no number, and this is the degree or the total number of relationship each number has. For instance, this number has 5 relationship or connection or actors connections. This one has 5, this one has 7, and so forth and so on. This is the number of degrees without taking or without considering whether it is in degree or it is out degree. Now I'm going to calculate in degree centrality. A node is in degree centrality refers to the number of ties or links it received. As far as calls are concerned, in degree centrality refers to the number of calls a number received. Let's run this comment. As I told you, or as I said that we have to change the mode by indicating that we are interested in degree or calls received. That when we are talking about in social media, it can be also, it can be, for instance, number of followers, or number of those who like your message or your message. Now let's learn to see in degree. Now to have a better presentation, I'm going to just to use data frame by learning this command. You see it is the same command because the command is the same, but I'm going to use data frame to have a better presentation, and this is just to print the results. Now I'm analyzing in degree centrality. Now as you can see here, friends, for instance, this number, the first number here, you see received one call. But remember, when I was analyzing all degree, this number has 5 degrees. That means other degrees are out degrees or outgoing calls. As far as we are talking about calls, this has in calls or has received 2 calls. This one has, this number has received 2 calls. This one has received 7 calls, and so on and so forth. Now, based on in-degree analysis, we can calculate what we call prestigious numbers or prestigious persons. A prestigious number is that one who has gotten many in calls. Remember when I was talking about the community analysis, hubs analysis, authority analysis. Normally, authority received many calls, while hubs make many outgoing calls. Now, this is the formula. Just to make normalization, you consider the number of degree divided by the number of nodes minus 1. Because a number cannot call itself. Now, before you perform this prestigious analysis or prestige analysis, you need this library dplyr. If you don't have it, the same for iGraph. If you don't have it, you need to install this dpr. Now, as I already have it, I do not need to install it again. Now I will use this command, but this dplyr library will allow me to use this function imitates, and also will help me to launch this by beginning by the greatest to smallest. Now, I'm going to, you see here calls. Here degree is when I saved the result from in degree, and I'm going to divide. This function is to count the number of nodes we have in call net minus 1 as indicated in this formula. This count will count the number of nodes, and minus 1 is just to apply this formula or to reduce minus 1. Now, if you run this comment, for instance, this one until here, no, this one, you will see the result. This comment, you will see we have 23 nodes minus 1 is 22. Now let's run this comment and save the result in calls in degree. Now I can just print. Now automatically I will see that number which got many incoming calls. Now this is to print the result. When I use this command round, it's just to reduce number after or the decimal number. I need after decimal number, I need only 2 numbers. Let's run this comment and you will see. Now, as you can see here, friends, by using the function around, I can see the results without any problem. As you can see here, that this is the number which got many calls. This is the next number. This is the next. This is the next, and so on and so forth. Okay, this is what we call prestige. Without having any problem, I can see automatically what we have said about authority, because we said that authority received many calls. Now this number is the one which got many incoming calls. So now we can continue and we can calculate out degree centrality. Out degree centrality allows to calculate outgoing calls or out links. Okay, now you see the comment. As I said, you just need to change here by indicating that you are interested in outgoing calls. Now that's why you see here out. That means which number a number has called, which number a given number has called outgoing calls. As you can see here, friends, for instance, this number calls this one calls this number calls this one, and we are analyzing these outgoing calls, this one. Now previously we saw incoming calls by analyzing in degree centrality. We were interested in these calls for this number. We were interested in this one, these coming calls, this for this one, these coming calls, what we call in degree centrality. Now you see this is the comment, but as I said, when you use this, the presentation is not good. That's why I have to use data frame to make a better presentation of our results. Now you see the comment here is the same as this one, and I save the result here in call out degree, and I'm going to use a data frame to have a better presentation. Now let's learn on this one, because this one is just to make a print to visualize the result. And let's learn, and you see the result. Let's click here. Now you can see here, friends, I have to calculate out degree. Look here, this is the result out degree, and as you can see here, for each number we have out degree. And remember, for instance, when we were analyzing in degree, this number has 1 in degree. But when we were analyzing the total degree, when we were analyzing all degree, this number has 5 degree. These 5 degrees are divided in 1 in degree centrality and 4 out degree centrality. Okay, friends, this is how you can analyze your social network. Remember, in the previous video I showed you how you can analyze density, which is the ratio between actual connection divided by the possible connections. Thank you, friends. I think this video will help you to increase the way you can analyze your social network. And if you found this video interesting, you can share it, and you can also subscribe to our channel not to miss the next video related to deep analysis of social network. Thank you for next video. Bye.